All right, welcome back to geometry. I hope that yesterday you completed your homework along with your baseball bat in a box assignment. Today we're continuing geometry and we're going into, I think it's section 8.3, continuing with the Pythagorean theorem. Classwork 157, we're going to look at the converse of the Pythagorean theorem. And homework 158, go ahead and write this down now, is page 296 to 297, class exercises 1 through 10, and written exercises 1 through 8 and 11 to 14. Have that written down. I will be collecting all of your homework when you return to school, since I have not received an email from a lot of you, and you will be having all of this homework due, so make sure you have it all done on the day that you return to school. Let's go ahead and get started today. Yesterday, sorry if my video was fuzzy, but I'm trying something new today. So our objective for today is to state and apply the converse of the Pythagorean theorem and related theorems about acute and obtuse triangles. So let's go ahead and recall back to chapter 2 what a converse statement was. What the Pythagorean theorem says is that if a triangle is a right triangle if the sum of the two smaller sides squared is equal to the hypotenuse squared. Well, here we're going to go in reverse, okay? The opposite, not really the opposite, but just reverse the order. And what theorem 8.3 says is it's the converse of the Pythagorean theorem. It says if the square of one side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. We're going to see in a couple of examples in a little bit when we're not going to have a right triangle. So let's go ahead and look at this triangle I have drawn for you on the board. Feel free to pause the video if you needed some time to write that down. But as we're going with the converse, it says that if the square of one side of a triangle is equal to the sum, if this is equal to this plus this, then this is a right triangle. So let's talk about this. I have 25, I already wrote it there for you. I have 25 off of 5 squared. I have 144 off of 12 squared. Does it equal 169? So I have 25 plus 144, 9, 6, 1. So yes, this is a right triangle because, opposite order of things, the square of my big side of my longest side is equal to the sum of the squares of the other two sides. Hope that makes sense. It's just the Pythagorean theorem reworded and switched. Let's go over here to some what are called Pythagorean triples. So you're going to start to notice that certain triangles you're going to like. We've worked with the 3, 4, 5 triangle already, and we're going to see it again today. The one that I just showed you right here is a 5, 12, 13. Another nice Pythagorean triple is an 8, 15, 17, and another nice one that's really rather large to build, but is a 7, 24, 25. Now, what you're also going to see is multiples of these. So if I have a 3, 4, 5, if I multiply 3, 4, and 5 by 2, I'm going to have a 6, 8, 10. Also a Pythagorean triple. 36 plus 64 equals 100. If I multiply by 3, I'm going to have a 9, 12, 15. Okay, 81, 120, or 144 is equal to, what do we got? 225. If I multiply by 4, I'll have 12, 16, 20, and so on. So Pythagorean triples aren't limited to just what I have written in orange here. It's also all the multiples. So if I multiply the side a length by 2, I'm going to have a Pythagorean triple. If I multiply it by 3, as long as I multiply each side length by the same number, I'm just going to maintain the Pythagorean triple status. So same thing here. I can multiply by 2 and I have a 10, 24, 26. I can multiply by 2 here and have a 16, 30, 34. I can multiply by 2 here and have a 14, 48, 50. And it would go so on and so forth. So it's a Pythagorean triple. The ones that you really need to commit to memory are these first ones that I have up here written in orange, because the rest of the Pythagorean triples, not the rest of them, but really common Pythagorean triples that you're going to come in contact with are the multiples of these top 4. Now there's a lot more, but these are the ones that you're going to see over and over and over again as we go through mathematics. All right, so if you need to go ahead and pause the video to absorb that, to finish writing that down, go ahead. And we are going to move on to the second part of our objective today. So they're the related theorems about acute and obtuse triangles. So we're going to look down on this desk here, and I'm so bummed you guys aren't here to do this with me. So hopefully we've got all of that in the frame there. This is a right triangle, and I've built it out of squares for you. So I have a Pythagorean triple, my 3, 4, 5. And this is the converse. My 9 squares here plus my 16 squares here is equal to my 25 squares here. So if this big square here is the sum of this medium and this small square, then this has to be a right triangle. Does that make sense? So I can go ahead and put in my mark for a right triangle. If you were here, I probably would have you count them. We could lay them on top of each other and prove that 9 plus 16 is equal to 25. And we could do this for any right triangle. All right, now bear with me because I'm going to move you over here to where I have some other stuff. Actually, stop, pause. This is Theorem 8.3. Be in the frame. Theorem 8.3 says that if c squared is equal to a squared plus b squared, then the measure of angle C is equal to 90 degrees and ABC is a right triangle. So this is Theorem 8.3. It's just another way of kind of stating the Pythagorean theorem, but it is a theorem in and of itself because it can be proven. Go ahead and write that down. Bear with me, sorry. I'm going to lift you guys up and bring you over here to my next triangle that I have built for you. Here. So what I have built for you here, sorry it's upside down in your frame. I had originally intended to have the camera on the other side. I have a 4, 4, 3. Now, there's an issue with this. My smaller side plus another side isn't equal to this side. 9 plus 16 is equal to 25, not 16. So this leads us to Theorem 8.4. Theorem 8.4 says that if c squared, being the longer side, is less than a squared plus b squared, then we can assume, we know, that the measure of angle C is less than 90, therefore not making it a right triangle and making it an acute triangle. So then we know that triangle ABC is acute. So make sure you have this down. And I'll re-explain it again in a second. So what this says is that if the sum of two sides is less than the sum of a longer side, then we know it's going to be an acute angle because I don't have a 90-degree angle. Let's go ahead and come over to this last example for today. Put it in there. All right. We have what I have is a 3, 4, 6. So I have my squares built off. I have 3 squared, which is 9, 4 squared, which is 16, and 6 squared, which is 36. Now, if this were a right triangle, I would say that 9 plus 16 equals 36. But we know that 9 plus 16 doesn't equal 36, it equals 25. So we can now look at Theorem 8.5. Theorem 8.5 says this: if c squared being the largest side, c squared being the longest side of a triangle, is greater than a squared plus b squared, then the measure of c squared is going to be more than 90 degrees. So if we go back and look at this angle right here, in between, adjacent to side lanes 3 and 4, this is obviously an obtuse angle. It definitely doesn't look right. Okay, a right angle, 90 degrees. So then we can assume that the measure of angle C is greater than 90. So look here, if C squared is greater than A squared plus B squared, then C is greater than 90, so it has to be obtuse. All of this should kind of flow together. It's not a hugely difficult connection to make in your brain. All right, let's go back. So this is all I need you to do for today. So again, let's go ahead and review. Here we had classwork 157, the converse of the Pythagorean theorem, with homework 158, pages 296 to 297, class exercises 1 to 10, and written exercises 1 to 8 and 11 to 14. If you have any questions, please feel free to email me, and I will try to answer all of your questions via email. And if I cannot, I will videotape myself answering your question. Have a great afternoon.